Today's lesson is from section 2.3, getting information from the graph of a function. Okay. Now here we're going to be looking at increasing, decreasing intervals, positive, negative intervals, and local mins and local maxes. So when we're looking at a graph of a function, we always want to read the function from left to right, just like you would in a book. So always make that the habit. Never look from the opposite direction. Okay, so as f is increasing, so notice that this one, as I move from left to right, going this way, so starting at negative infinity and heading to infinity, the first point I come to is x comma f of x sub 1, and then I go to x sub 2 comma f of x sub 2. So remember, the f of x sub 1 is representing the y value, the x sub 1 is just the x. So they're just kind of keeping them separate with the subscript there. So clearly in this one, as you move from x sub 1 to x sub 2, you are increasing. You're heading upwards. It has like a positive slope. So that's kind of the thought process you're looking for. So when the first point is, the first y value is smaller than the second y value, then you are increasing. But then on the flip side, if your y value is greater for a smaller x, as you go to the right from negative infinity to positive infinity, then you're obviously decreasing. So it has like a negative slope. So it's always easiest to kind of look at these like with your slope in mind, just visually. You don't have to find the slope. It's just that's a good visual to help you kind of determine when it's increasing, when it's decreasing. But always look left to right. So let's try working with this. So example 1, our sketch of the graph for the function x cubed minus 6x squared plus 10. And we want to state those increasing and decreasing intervals. So here I already have a function graph for us of this function given. And so as I move from negative infinity, I want to head to a point where I see, oh, I stopped increasing. So in this one, our top point on this one would be at 0, 10. So 0 would be that x value where it stops increasing, but just before it's going to become decreasing. So I would say, using interval notation, negative infinity to 0, and because at that point you're neither increasing or decreasing anymore, you're like in an in-between spot. So you can think of like a roller coaster where you get up to the top of it and they stop you just before they're going to release it, and then you're going to head down to actually ride the ride. That's kind of the thought that we have. So in calculus, though, if we're looking at these functions, you would actually take the derivative for those, for the mins and the maxes, and they would be 0 at those points in the graph or in the function. So that is why it's not increasing, decreasing, because the derivative actually tells you the slope of the function at any given point. So from there, next one would be from 0. Now notice that I'm not including 0, so that's why it's parentheses. I keep going, and then the next one would be at 4, because that's when I hit the valley there. So it's not decreasing anymore, but just before it starts becoming increasing again. And then it shoots back up. So I have another increasing interval from 4 to infinity, and I'm going to use the union sign to kind of join those two. Now sometimes you have just 2 intervals, sometimes you may have 4 intervals, 2 for each, or like it kind of just depends on the function and how many local mins and local maxes you actually have in the function. Okay. Moving on to the next one. Here we want to talk about your function when it's positive, negative, and those intervals. So remember, f of x is representing your y value, so you're still kind of looking at the y. But when your function is a positive or has positive interval, that means that your function is above the y-axis. And then when your function is negative on an interval, that means your y values are negative, so below the y-axis, okay? So example 2 wants us to state the positive and negative intervals for the function of x cubed minus 2x squared minus 5x plus 6, okay? So I have that graph down here at the bottom for you. Now here, our key point or key line is we're looking at the x-axis and where it crosses. So I need to know where those x values are as I'm considering going from left to right. So I go from negative infinity, and it looks like, and so for my scale I'm going, every tick mark is 2 in all directions. And so it looks like I hit the value of negative 2. So the first one, since it's below the y-axis or x-axis, I would say from negative infinity to negative 2. And then I would continue up above the y-axis for a positive interval, and it looks like I get to positive 1. So from negative 2 to 1 would be my first positive interval, and then I go back down below, and I get to 4. So union for negative, so 1 to 4, parenthesis, so not including those values on the x-axis. And then the last one, you start at 4 and head to infinity. So union 4 to infinity. Okay, and so like this one has 4 intervals, 4 separate ones, 2 positive, 2 negative. Okay. All right. Now our last slide. Now we're going to talk about those local mins and local maxes. So local max is just a maximum value on your function in a given interval. So, and the local min is a minimum value of the function in a given interval. So like if for this example, we want to look back at our previous examples and kind of locate what those mins and maxes are. Now it's kind of nice because when you're doing these, you kind of have to figure out what the mins and maxes anyway are, like so that you can actually graph them. So like here, I already placed them down when I graphed them. So I found 0, 10, and 4, negative 22. So I already know what those are. Now, if you were thinking like, well, the max is actually infinity and the min is negative infinity. Now, you could literally say that about any function or most functions, except the ones that are parabolas. And that's like not a fun thing to talk about. It's kind of redundant. We care about more of like where those points of inflection are, so where it kind of turns or does different things in your function. So that's why we kind of shrink it down to where local mins and local maxes happen. Okay, so for our first example, your min would be at 4, negative 22, and your max would be at 0, 10. Now I'm just going to write these as ordered pairs. I know the book in the the answer keys will say minimum of negative 22 at x equals 4, but that's a lot of writing when you could just really say the same thing with an ordered pair. So I would probably ask you to write an ordered pair for these. Okay. Now let's go back to the last picture for example 2. In example 2, now these ones are a little bit harder. Sometimes they land on nice points like the first one. This one they don't. So I have a maximum at negative 0.8, 8.2. So it's pretty close to something nice, but not quite. And then my minimum is going to be negative 2.1, negative 4.1. Okay? And so here, most of the time, let's just round to the tenths for most of our stuff, because after that, we don't really need that detailed of ordered pairs. The first decimal place works good enough for that, to know that it's not completely on two integers. Okay? So that's all we're talking about here. So Have fun.